In this video, we'll go over the physical connection and initial software configuration of all the components in an inline OD measurement and control system. All of the equipment we will cover can be seen here. We have a laser micrometer and an I/O device, all connected to a network switch that sends data to a PC which is running the TotalVu software. To get started, you can unbox your PC and monitors. Go ahead and plug the PC and monitors into power, then press the power button on the PC to turn it on. If you bought the PC from LaserLinc, much of the computer setup has been completed for you, including the installation of TotalVu software. If you did not buy the PC from LaserLinc, you will have received a USB stick with your order containing the install set for TotalVu. We'll talk more about the software configuration toward the end of this video. Next, we'll connect the PC to the network switch. We will use this switch to connect all LaserLinc equipment to the computer on a static, local IP network. This switch should only be used for LaserLinc equipment. Any other network devices that will be connected to the computer should use a separate network port or NIC port. To connect the switch to the computer, plug one end of the Ethernet cable into any port on the switch. Plug the other end of the Ethernet cable into the network port on the back of your computer. If your computer only has one network port and you want to connect your PC to your plant network, you should use the USB to Ethernet adapter that came with the order. We're going to wait to power the switch until all other equipment has been connected. Now we'll connect the laser micrometer. This particular gauge is a Triton 330, which has 3 axes of measurement and is capable of measuring parts up to 1.15 inches in diameter or 29.21 millimeters. LaserLinc micrometers can be powered a few different ways depending on the model. The first method is a standard AC power cable. If you have a gauge with a connector panel that has the standard male 3-prong plug like this one, you can take a standard power cable, plug it into the gauge, and then plug the other end into an AC outlet. The second type is powered with a 12-volt power supply. Using the provided power supply, plug the matching plug into the port on the scanner and the other end into an AC outlet. For both of these power options, be sure to connect the gauge to the switch via an Ethernet cable. The final power type is PoE, or Power over Ethernet. If you have a PoE switch, you can power the gauge by connecting it to the PoE switch with an Ethernet cable. If you do not have a PoE switch, you can use a PoE injector to supply power to the gauge over Ethernet. First, connect the switch to the data port on the injector with an Ethernet cable, and connect the gauge to the power port on the injector with another Ethernet cable. Again, we will wait toward the end of this tutorial to plug the switch or injector into power. Next, we'll connect the encoder cable to the micrometer so that the software can track the length of product running through the gauge as measurements are taken. If using an encoder wheel, you will need a cable with a crown connector like this at one end and a high-rosy connection like this at the other. Connect the high-rosy end of the cable to the micrometer and the crowned end of the cable to the encoder. If you will be using an encoder signal from a polar or similar machine, you will need a flying lead to high-rosy cable. Here is the high-rosy end again, and here is the flying lead end. You will need to wire the flying lead end of the cable to your encoder signal source. Which wires to use will depend on the type of signal coming from the machine. If the machine has a quadrature signal available, meaning the encoder can count forwards or backwards, you'll wire all 4 signal wires. This includes A+, A-, the white-black twisted pair, and B+, B-, the green-black twisted pair. If quadrature isn't available, meaning the encoder only counts in one direction, you can just use A+, A-. Using A+, A- will provide a differential signal, meaning that the signal is measured as a voltage difference between the 2 wires. This signal type is preferable as it is much more resistant to outside electrical noise. There is also a single-ended signal type, which uses the ground wire as a reference. This means you would only use A+, B+, and ground for quadrature, or A+, and ground for non-quadrature. The ground wire is the black wire in the red-black twisted pair. However, using this signal type is generally not recommended because of its susceptibility to noise. You will only wire the ground wire if you want a single-ended signal. You will only use the power wire, which is the red wire from the red-black twisted pair, if the gauge will be powering the encoder, as is the case with an encoder wheel. Most often, when using a flying leads cable, the encoder is powered by another power source. In this case, do not wire the red flying lead wire, as this can damage the electronics inside the gauge. Be sure to protect exposed, unused, flying lead wires before powering the gauge. When you have finished wiring the flying leads into the encoder source, connect the high-rosy end of the cable to the micrometer. With the connection of the encoder, that completes the hardware setup for the laser micrometer. After all devices have been connected to the switch and prepped for connection to power, begin powering on the devices. If your micrometer has a rocker switch on it, flip it to the on position. At this point, the motor inside the laser micrometer will begin spinning up. Do not move the micrometer while powered on, as this can damage the motor bearings and potentially prevent it from working. Once all the equipment is powered on and physically connected to the computer, we'll verify that everything is communicating with the TotalVu software. If you purchased your computer from LaserLinc, TotalVu will already be installed and the appropriate serial numbers and IP addresses will already be set in the software. If you did not purchase your computer from LaserLinc, you will need to complete some computer setup and install TotalVu with the USB stick provided with your order. Before installing the software, you'll want to ensure that you are signed into an administrator account, as most of the following steps will require administrator privileges. First, we'll adjust the user account control settings. To change your user account control settings, navigate to Control Panel, then click User Accounts, and then User Accounts again. Click Change User Account Control Settings, then drag the bar all the way to the bottom to Never Notify, and click OK. Next, you'll need to ensure that your computer's network port is assigned a static IP address. Navigate back to the Control Panel Home, click Network and Internet, then Network and Sharing Center. On the left, choose Change Adapter Settings, then click on the network adapter corresponding to the physical connection to the new switch. If you have multiple network ports in use on your computer, it may be useful to unplug and replug the switch connection to verify which Ethernet adapter you'll need to set. When you unplug the switch's Ethernet cable, a red X will appear on the network adapter icon that was disconnected from. Once the network connection is identified, double-click to open it, then open its properties, double-click on the TCP IP v4 address setting, then click the radio button next to Use the following IP address, and assign a static IP address. Use a subnet mask of 255.255.255.0, then click OK to complete the IP address configuration. Once these computer settings have been updated, we can install TotalVu. To install TotalVu, plug the USB stick into the computer and view its contents. There will be several objects on the drive, including readmeinstall.htm, setup32.exe, and setup64.exe. The readmeinstall.htm file will provide additional instruction and tutorial videos for the setup and use of LaserLinc hardware and TotalVu software. The setup32.exe and setup64.exe will install TotalVu and correspond to the version of Windows installed on your PC, 32 or 64-bit. This information is located in the System and Security Settings and Control Panel. Under the System Settings, look for the System Type information in the System section of the resulting View Basic Information about your computer page. Run the setup.exe corresponding to your system type as an administrator, accepting all defaults. Once the exe finishes running, click to finish the installation. At this point, you will be prompted to restart your computer. Go ahead and reboot now. Once the system reboots, we have one final piece of computer setup to complete, which is to add exceptions for TotalVu to the firewall. To do this, open Control Panel and navigate to the System and Security settings. Click Windows Defender Firewall, then click Advanced Settings. Open the list of inbound rules, then click to add a new rule. This will be a program rule. For the program path, use the Browse button to navigate to TotalVu.exe within the TotalVu installation directory. The default installation directory path is C drive, LaserLinc, TotalVu. Allow the connection and ensure that the rule applies to domain, private, and public networks. Name your rule TotalVu Software or another name to reflect the rule applies to the TotalVu program. Now repeat the same steps to create a new outbound rule. When creating the outbound rule, be sure to click Allow the connection, as this is not automatically selected for the outbound rule. Now, open TotalVu by double-clicking on the TotalVu desktop icon. We will use TotalVu to verify that the new equipment is able to communicate with the computer. We'll start with the micrometer. On the keyboard, press Ctrl-C to open the full configuration menu. Double-click on the gauge icon, then click on the icon of the predefined micrometer. Ensure that the serial number entered in the software matches the serial number listed on the laser micrometer. Navigate to the NetLinc tab and verify that the host IP address is set to the static IP address assigned to the computer's network port. Verify that the device IP is a static IP address that is compatible with the host IP. This will ensure that the gauge is on the same network as the computer. Exit out of the full configuration menu, then press the F4 function key or the Ctrl-U key combination to open the general status window. Select your gauge from the drop-down at the top of the window. If the gauge is communicating properly, we should see two edges for each axis when nothing is in the field. If you put something in the field, for example your finger, you should see the edge count increase to 4 for each axis. The reported measurement rate should be steady as well. The measurement rate depends on the model of the gauge. Please visit our website at www.laserlinc.com/products and choose the gauge you have to view its measurement rate and additional details. Close out of the general status window and view the main display. Verify that the encoder signal is properly coming through by checking that the length value is counting as the encoder is ticking. If the length value is updating successfully, the speed value should also be updating. Next, we'll check the NetIO. Press Ctrl-C to open the full configuration menu and click on the NetIO icon. Then click on the predefined NetIO device. Again, verify that the serial number and host IP address are correct. Check that the device IP address is compatible with the computer's network and that it is not assigned the same IP address as the gauge. Once complete, press OK. If any changes were made, TotalVu will ask to restart. To tell that the NetIO is communicating, view the process tracker or error log and look for a message stating the NetIO is connected. We can also perform tests to confirm successful connection by executing actions in TotalVu that should translate into relay actuations. For example, if the NetIO is connected to a light stack where the various colors are associated with various alarms in TotalVu, we can manually turn on and off the alarms and watch to see that the relays are actuating properly. After verifying that all components of the system are communicating properly, you may begin using the configuration to create recipes and configure the control settings. For more information regarding how to use the configuration, refer to the Configurations User Guide, which can be accessed by clicking the User's Guide button in the Settings menu under Utilities. For more general information about how to use TotalVu, refer to the Documents folder in your TotalVu installation directory. The default installation directory location is C Drive, LaserLinc, TotalVu. This folder contains tutorial videos and quick start guides to walk you through common setup practices. If you run into any challenges at any point during the setup of your new equipment, feel free to reach out to our tech support staff via the Quick Support button in the Settings menu under Utilities. This will get you connected with someone who can remote into your system and assist with setup or troubleshooting. We'll be happy to help. Thank you for your business, and thank you for watching.